We're dealing with rational expressions here. And to start off, we first need to look at how we simplify our rational expressions. Well, we don't know what a rational expression is, we can't simplify it. It's an algebraic fraction whose numerator and denominator are polynomials. Well, that's pretty broad. So let's just write a few examples up here. Well, it's a fraction with polynomials. So basically anything with like numbers and variables, and we'll kind of expand on that. So like 2 over x squared. There you go. That's a rational expression. You could bring binomials into play. You might have something like x squared minus 4 over 12x. So there we go. We have a binomial up top. And if you notice, it's actually a difference of squares. So I could factor that. And we're going to get into that. And even to go further, I could have a trinomial, or more specific, a quadratic somewhere in my fraction. So I could have something like this. I might have h squared minus 16 over h squared plus 4h minus 8. There's something else. So I'd have a quadratic down low, a difference of squares up top. You could have all kinds of different things. Well, and when we simplify these guys, we're going to state things that are excluded values. And an excluded value, why it's important, is because if you notice up here, in all 3 of these irrational expressions, I have variables in the denominator. Well, we can never have a 0 in the denominator. So the denominator cannot have a 0. Because think about this. I can have a 0 up top. I could take like 0 divided by 4. I could break 0 into 4 equal parts, right? 0, 0, 0, and 0. That's why it's 0. But can I take 4 and break it into 0 equal parts? No, that doesn't make any sense. You get an error if you type it in your calculator. So that's why we cannot have a 0 in the denominator. So for example, if I look at this first guy up here, this first rational expression, x cannot be 0 because that would make the denominator 0. So that would be an excluded value. 0 would not work. I could plug any other number in for x in for this first expression, right? I could plug in a 4 and get some answer, but I can't plug in a 0 because that makes the denominator 0. That's why we call it an excluded value. So let's try that. We're just going to simply state the excluded value for each expression. The nice part, whenever I just state the excluded value, all you got to do is just pay attention to the denominator. Well, and the easy way to do it, for some of these like this, pretty straightforward. What could I put in for b to make the denominator 0? Or saying like what plus 7 is 0? Well, b would be negative 7 to make that 0. So state the excluded value. So we want to say b cannot equal negative 7. That's how we state our excluded values. And to be more specific, what we want to do is take our denominator and set it equal to 0 and then solve. That's how I do it, like completely mathematically. So b cannot be negative 7. So that would be my excluded value. Looking at 2, now this is where you actually you might want to write it on the side. Some of you might not see this as easily. So what can I put in for x to make the denominator 0? That would be our excluded value. Well, I could write it on the side over here. So I could subtract 1. Right, we set that denominator equal to 0. And 2x equals negative 1 and divide by 2. So x cannot equal negative 1/2. So my excluded value. So I always say cannot equal for excluded because we're saying what x can't be. And my quick shortcut, if you remember, well, what do you want this entire thing to be? Well, you want it to be negative 1. And to cancel the 2, you have to have a 2 in the denominator. So negative 1/2. Remember our quick trick? We did that way back when we were factoring and solving quadratics. And lastly, oh boy, now look at the bottom. We have a quadratic, okay? Luckily, there's no coefficient in front of this a squared. So what we want to do is we want to factor this guy to help us figure out how I can make the denominator 0. What can I plug in for a to make that denominator 0? So if I wrote it on the side, a squared minus a minus 12 equals 0. Remember, whenever I have a quadratic equal to 0, we want to factor it. So we're looking for factors of negative 12 that add up to negative 1. Remember, there's an imaginary 1 there in front of the A. And if I think about it, looks like 4 and 3, and which one would have to be negative? The 4. So negative 4 and positive 3. So really what happens is, over here I have A minus 4 times A plus 3. And if I looked at it, when I had it set it equal to 0, so I have A minus 4 times A plus 3. To make this equation true, I could say A could be 4 or A could be negative 3. Right? Because I could plug in negative 3 to make that 0. I could plug in 4 there to make that 0. So our excluded values would be A cannot equal 4 or negative 3. And most of us should be able to look in here once we write it in factored form that, oh yeah, if I put a 4 in there, that makes that 0. If I put a negative 3 in there, that makes that 0. And 0 times anything is 0. So you always want to factor whenever you're given that quadratic. Well, now we're going to simplify the expression and state the excluded values. So first things first, you always want to look for excluded values first. See if you can state any excluded values. Because once you start simplifying, you might simplify something and not see one of the excluded values. So if I look right here, can I tell what would make this 0? Not yet. But what should I do to that guy? Well, just what we did to the last one. We want to factor it. So we want to find factors of 21 that add up to 10. And in this case, what do we have? 7 and 3, positive 7 and positive 3. So I'm going to have n plus 7 and n plus 3. So right when I factor, so I'm going to rewrite this. So that replaces it. So really we have n plus 3 over n plus 7 times n plus 3. So state your excluded values right away when you can. So if I look, well, if I put in a negative 7 and a negative 3, that would make the whole denominator 0. So that's what n cannot be. So do that right away. So n cannot be negative 7 or negative 3. So I got my excluded values. But if I look, can I simplify this? Yeah, if you notice, here's some number n plus 3. Here's some number n plus 3. Those cancel with each other because they're the exact same number. And I have multiplication right here, so it allows me to cancel. So this n plus 3 cancels with this n plus 3. And what's left? Well, there's not a 0 up top. There's really still just 1. Because we're really dividing the top and bottom by n plus 3. And down below, we just have n plus 7 left over. And now I'm done. I can't simplify anything anymore. And what would happen is, if I simplified all the way and then looked at excluded values, the only one that you think would work would be negative 7. Right? Because that's what it is in simplified form. So that's why we do it as early as we can. That's why I looked right here, because I have negative 7 and negative 3 for the excluded values. So it gets to be a little tricky. So always look for excluded values first while you're simplifying. So like for number 2, this will be a little bit easier to see. Let's look for excluded values right away. Well, what can I plug in here? I might be able to do this mentally. You want this whole thing to be negative 10. So 2 times what gives you negative 10? Well, 2 times negative 5 gives you negative 10. So I know that n, or y, why'd I put n? I used to use n's. So y cannot be negative 5. So state that excluded value right off the bat before you start simplifying. So there's my excluded value. Now let's go ahead and simplify. Well, up top, we have a quadratic. So y squared plus 9y, it should be a squared. Oh, I'm sorry about that. Y squared plus 9y minus 10. So we're looking at factors of negative 10 that add up to 9. Well, we're using a lot of our factored form stuff here. So we got 10 and 9. And which one has to be negative? Well, we need, oh, not 10. 10 and 1, my fault. 10 and 1. I'm looking for 9. So we need a negative 1, right? Because I want to keep a positive 9, because 10 plus negative 1. I'm going through this kind of quick because we should know how to factor by now. So I'm going to replace this top part with, give me some space here. Replace the top part with y minus 1 and y plus 10. Right? It doesn't matter what order you put those in. Well, what about down below? It's not a quadratic, it's not a difference of squares, but you always should look to see if you can factor something out. Well, I can pull out a 2, right? Each of these has a 2 I can factor out. Divide a 2 by each term. So I'll pull out that 2. What's left? Y plus 5. Okay, so let me rewrite what we have here now. So up top we have y minus 1 times y plus 10 all over 2 times y plus 5. And if I take a look, does anything cancel? Nope. So I'm done. And that actually helps me justify my excluded value, right? Y cannot be negative 5. If I look right there. Very good. All right, here we go. Simplify expression, state the excluded. So we're still doing the same thing. And let's just look closely. So looking at the first guy up top. Well, can I factor anything out? Nope. So then we always look for, is it a difference of squares, right? Anytime it's a binomial, well, I got a difference. And can I square root both these? Yep, perfect square. I can square root that. Good to go. And how does our difference of squares break up into? Our two binomials that have different signs. And we just take the square root of each. So the square root of 25 is 5. So that's our first term. And the square root of x squared is x. So that's our second term. So I replace that. So let's write this over here. 5 plus x, 5 minus x. Oh, I'm already jumping the gun, aren't I? Maybe I should see what my excluded value is here. Well, as long as I don't cancel anything out, I should be okay to state my excluded value after I factor. So now looking here, can I factor anything out on the bottom? Sure, we can factor out at 8. So what's left? X minus 5. And is x minus 5, is that a difference of squares? Nope. So we write 8 times x minus 5. So what's my excluded value here? So now I want to state it before I simplify anything further. So x cannot be positive 5, right? Put a 5 in there, that makes that 0. 0 times 8 is 0. And if I look, does that x minus 5 in the blue cancel with anything up top? No, they're just a little bit different. So this is simplified form as well. Nothing cancels. All right. And lastly, it says find the zeros of the function. The zeros of the function. So basically that just means when my function is 0, what do I get for x? So all we're going to do is plug in 0 for the f of x. And that equals x squared plus 8x plus 7 over x plus 1. And to do this, we need to factor and simplify. Kind of like we did before when we had quadratics equal to 0. So let's go ahead. Bottom looks good. Up top, let's factor it. So factors of 7 that add up to 8, 7 and 1. So we have x plus 7 and x plus 1. So I replace that. And if I take a look, this is where you start doing some shortcuts. I don't need to rewrite this whole thing out. If I look, I have an x plus 1 and an x plus 1. So they would cancel with each other. So now what's left? I have a 0 equals, well, I have x plus 7 up top. And down low, I really have 1. But do I need to write that? Anything over 1 is just itself. So x would equal what? Negative 7. That would be the 0 of the function. Negative 7. And that's all there is to it. So just a few things starting to get into our rational expressions.